Polar coordinates. Polar coordinates offer an alternative way of locating points in a plane. We're very familiar with the idea of Cartesian coordinates, where we just have an xy axis, and any point can be described by the x coordinate and the y coordinate. The polar coordinates are useful because of certain types of regions and curves. Polar coordinates provide very simple descriptions, and the equations are really very simplistic. The principal applications of this idea occur in multivariable calculus, which is the evaluation of double integrals, and the derivation of Kepler's laws of planetary motion. Now, polar coordinates are based on what's known as a pole, which is the origin in the plane, and an initial ray called the polar axes. So basically, if I think of my xy coordinates, I'm going to make the origin what we think of as x0, and x is 0, y is 0. And then my initial ray, called the polar axes, I'm going to go along the x-axis. Now from here, once I've identified this, I can take any point, like right here, what we think of as an xy. I can now describe this exact position, what we love and adore as xy, as a distance from the origin, r, the radius, and the angle theta. So if I start at 0 degrees and I know what angle to go to and I know how far to go, I can describe any point in the plane. The coordinates, we use an ordered pair, r and theta, which is a directed distance and a directed angle. The directed distance is actually pretty important, because this r, this distance we're traveling, could be positive or negative. It's a directive distance. We know distances are always positive, but directed distances tell me which direction. And I'll talk about that more in just a second. Okay, unlike rectangular coordinates, polar coordinates are not unique. So, as an example, the point 2 and pi over 4 is identical to the point 2 and 8n plus 1 pi over 4 for n equals 0, 1, 2, 3, and so forth. Now, let's just find this point first. What this is saying is I'm going to come up at an angle of pi over 4, and this distance r is going to be r equals 2. So I'm going to come out that far, and right there is the point 2 and pi over 4. Now it's suggesting that I could write it in this form too. Well, for n equals 0, this is 2 and pi over 4. But if n equals 1, then I'll have the coordinates 2 and 8 plus 1 pi over 4. Well, that is 2 and 9 pi over 4. Well, where's 9 pi over 4? Well, 4 goes into 9 twice, so that's 2 pi. So in other words, I start at the origin, I start at 0, I'm going to go around to 2 pi. And once I hit 2 pi, I have a pi over 4 left over. So I'm going to come up another pi over 4, and there I am, exactly where I was before, with the same distance. But this is also saying I could represent this as a negative 2 and 5 pi over 4. So let me start over here. So if I go 5 pi over 4, here's 0, I'm going to come around, that's 5 pi over 4. But now it's saying I can represent the distance as a directed distance, negative 2. Well, rather than going 2 in this direction, I'm going to go negative 2, which means I'm going to go the opposite direction that I'm pointing. See, this 5 pi over 4, you would think I'm pointing in this direction, but because of the negative 2, I'm going to go the opposite direction, and there I am again at that same point. In general, the point r theta can be represented as r and theta plus 2 pi, which makes sense because if you pick an angle theta, and if I add 2 pi to it, I'm going to come all the way around again. For every 2 pi, I'm going to keep coming around. Or I can represent it as a negative r in theta plus 2n plus 1 pi. Well, 2n plus 1, that's how we always get an odd integer. So what this is saying is an odd pi. Well, I'll think about that for a moment. I'm going to draw one more little graph here. Let's say that this is my original point. So if I start here and I do an odd pi, well, here's 2 pi. 3 pi bring me back to here, so it'll be like this. But with r being negative, I would literally go in the opposite direction. So there I am again, right where I started from. So here's 2 ways that we can, well actually 3 ways, we can represent the same point in the plane using polar coordinates.